Right. Homework. That's life. Right. Yes, come on. Hey, why are you late? You're late? Yeah. Sit down. Alright, first question was if the charge on a particle is doubled, then what happens to the force?
The force doubles.
Yeah, because you have E equals F over Q, F equals EQ, so if the Q is multiplied by 2, then the F is multiplied by 2 as well. So the F also doubles. 2. A 1 microgram particle of charge 1 millicoulomb is attracted towards the center of an electric field. The field causes the particle to accelerate a distance 1 centimeter in 1 second. How strong is the field? So what's happening here is you have a field and you have a particle here, and its charge is 10 to the minus 3 coulombs, and there's a force pulling on it, of course. Now you can work out the do we know the mass? We do. The mass is 10 to the minus 6 kilograms. So you have your UVATS. The U is 0, V we don't know, A we don't know, T is 0, T is 1, S is 0.01. So if we just use F equals UT plus a half A T squared, then we get that A must equal 0.02 meters per second squared. But Newton tells us that F equals ma, so that would be 0.
The mass is 1 microgram.
Correct.
So that's 10 to the power minus 6 gram.
Why, thank you. Also, I really wanted to say microkilogram? Microgram. I don't want to use grams. Bleh.
So that would be minus 9.
But then I don't say microkilograms because that's ugly. Alright, I'll just change it. I'll change it. So we'll fix that in a minute. Where was I? Okay, the mass is a microgram. So that's, as you said, 10 to the minus 6 grams. Now we don't want grams, we want to use it in kilograms. So if I divide by 1,000 again,
Minus 9.
yes. That's tiny.
And 10 to the power.
So that's 2 times 10 to the minus 11 is the force. Yeah.
Does that mean 10 power minus 6 and 10 minus 1?
Yeah, I'm changing it from grams to kilograms.
Yeah, I know, but why did you write it like that?
Why what?
10 power minus 6, and then what's between
10 minus 3, 0.02. So this is the micro part.
They are not multiplying each other, or what?
Yes.
Okay.
Yeah. Okay, so finally, E equals F over Q, which equals 2 times 10 to the minus 11 over 10 to the minus 3, which equals 2 times 10 to the minus 8 newtons per coulomb. Okay, so that's that one. Can I do the next one? Let's see now. 2 milligram dust particle falls from one copper plate to a lower copper plate, a distance of 10 centimeters, and it took 10 seconds to do so, and the charge was minus 200 electrons. Constant. What was the electric field strength during the fall? So it's 2 milligrams. So let's get that right first.
Milligrams.
So 2 milligrams equals 2 times 10 to the minus 3 grams, which equals 2 times 10 to the minus 3 kilograms over
1,000.
kilo, which is 1,000. So 2 times 10 to the minus 3 times 10 to the minus 3 kilograms. So 2 times 10 to the minus 6 kilograms. So you have one plate, another plate, and the particle falls. And I tell you, the U is 0, the V we don't know, the S is 0.10, the T is 10. S equals UT plus a half A T squared. So 0.10 equals 50A. So A equals 0.10 divided by 50, which is 0.002 meters per second squared. How many forces are acting on the particle, by the way?
2.
2. Weight and the electric field is lifting it a little. So you know that W minus F, that's equal to the total force. But Newton says force is ma. So W minus F equals 2 times 10 to the minus 6 times 0.002. W is mg and F is EQ. What? What's wrong?
Why do you subtract W and F?
To get the total force.
So the total force is what we've calculated before.
We haven't calculated force yet. This acceleration is the total acceleration. So, do we know the M? We do. Do we know the G? We do. Do we know the Q? What did I say? Was 200 electrons?
Minus electrons.
Yeah, minus. Well, I'm not worried about the sign because I have the minus there already. So that's okay. What did I say the mass was? 2 times 10 to the 6. Okay. 2 times 10 to the minus 6 times 9.81 minus E times 200 E equals 2 times 10 to the minus 6 times 0.002. So do a good bit of cleaning up and you get E equals 2 times 10 to the minus 6 times 9.81 minus 2 times 10 to the minus 6 times 0.002 all over 200 E, and E is 1.6 times 10 to the minus 19. So if we type all of that in, 2 times 10 to the minus 6 times 9.81 you get 6.13 times 10 to the 11 newtons per coulomb. KJ, who are you texting or WhatsApping or Twittering or Facebooking or Snapchatting? Who are you I aming?
Check.
Tell me. Who?
Nobody.
Nobody. That's a nice way to talk to your friends.
Then no one.
They're nobodies. You know, tell them. That's what KJ thinks of his friends. They're nobodies. Alright, next one.
Oh, this one was
Second.
confusing.
Good.
It looked like he was nodding off about my protection.
Do you reckon? I'm sorry, Fahad, I need to continue. Everybody else is finished. One electron orbits one proton with a 10 to the minus 10 radius. The strength of the electron field is 1.4 times 10 to the minus 10. What's the time? Okay. So, I got a proton, an electron, and it's orbiting. So far, so good? We know the charge here is plus E, the charge here is minus E, and the radius is 10 to the minus 10. And the electric field strength here is 1.4 times 10 to the minus 10 newtons per coulomb. So far so good? Yeah? Okay. So what's the force at the electron?
EQ.
EQ. And what's the E? 1.4 times 10 to the minus 10. And what's the Q? It's, I still can get it back on my calculator. Come on. What numbers for constants? 7, isn't it? No.
What's the E?
Shift 7, 23. Right, the E is 1.6 times 10 to the minus 19. So let me just calculate that. That's the force. What type of motion is this?
Circular.
So this electric field is causing a circular motion. So you also know that m omega squared or is equal to this. Oh dang, now it makes sense. So do you know the or?
Yes.
And do you know the mass of an electron?
Yes.
So if we just do a division, we can get that omega is square root 2.24 times 10 to the minus 29 over 10 to the minus 10, and the mass of an electron is small. It is 9.11 times 10 to the minus 31. So if I hit that into the calculator, I get omega is 495,833 radians a second. But don't forget that T equals 2 pi over omega. So your time will be 1.26 times 10 to the minus 5 seconds. Or if you want, that is 12.67 microseconds. What do you think about that?
How did you originate that?
Yes, definitely. You haven't forgotten everything you learned in circular motion, have you?
No, but I know those things with experiences.
It's an electron orbiting a proton. How more circular could you get? Next. 2-meter wire of thickness 2 millimeters in a circuit An electric field is placed around the wire, and as a result, the electrons move. An ammeter records the readings of 3 amps. Yeah, delete it. No, forget about it. It's a silly question.
I don't know, I think we're looking too long.
You didn't attempt it?
No.
Yeah, so we'll just delete it. Alright. We'll continue, so. Let me just kill it.
Rest in peace.
Yes, rest in peace indeed.